This is the page for the second link of the hierarchical cluster analysis links that I gave in the PowerPoint. So in this link it says, with the distance matrix found in previous tutorial, we can use various techniques of cluster analysis. So we can ignore the distance matrix found in the previous tutorial because that's a separate tutorial. But this is just another example of the use of hierarchical clustering on a dataset that's built in R. For example, in the dataset mtcars, so this is a dataset in R, we don't have to import it. We can run the distance matrix with hclust, we've already seen this function before, and plot the dendrogram that displays a hierarchical relationship among the vehicles. So let's look through the code. It says here, like before, it changes the mtcars dataset into matrix and then calculates the distance and puts it inside D, and then the cluster analysis is done on D and plot the HC. So let me try this code by code in R. So let's see mtcars. How do we load that? So to load the built-in dataset in R, we just type in data and then type mtcars and press enter, and you see the mtcars there. And if you want to take a look at what it looks like, you can just type mtcars and it will change that variable into the data frame. So click on that and you see the list of cars and also the characteristics of those cars for those different types of cars. Close this. Okay, so now we viewed it, what it looks like. So now we need to change it to from a data frame into a matrix, so that's why there's this function as matrix mtcars. So let me just run it here so we know what it looks like. So it looks the same as the data frame, except for now it's in the format of a matrix instead of a data frame. Let me close this. But it doesn't really do anything to this variable here, it just displays it because we did not assign it to anything. Now going back, we go to the next line, which is distance. Calculate the distance, and this will calculate the distance between each of those points inside the matrix. And then we have the distance calculated between each points. Then we run cluster analysis. But first we need to define D here. If you notice just now, I just run S matrix mtcars to change it to matrix and then calculate the distance, but we didn't assign it to anything, so we need to actually write this code in R and then run it. Now we see the matrix, the distance calculated inside D here, and we run hclust on that with the function D. Press enter and you see the same thing as what we saw in the previous example. So the default method for the cluster analysis is complete, and the distance calculator is using Euclidean, and the number of rows is 32. But we want to plot the dendrogram, so we need to assign the values of this analysis into a variable. So the one given here is HC. We copy that, paste this here, and then you see the HC is defined, then we plot HC. There we see the dendrogram. So here is a bit more interesting to see because you'll be able to look at the names of the cars in the different clusters. So like before, you can cut this into groups based on the height. So if I cut it from here, there's 1, 2, 3 groups of cars, and if I cut it from here, there's 1, 2, 3, 4 cars. Let's go to the next explanation. It says here, careful inspection of the dendrogram shows that the 1974 Pontiac Firebird and the Camaro Z28 are classified as close relatives as expected. So this is for those car aficionados who are well versed with the car models. So they say that these two cars are related or are close relatives as it's stated here, and then that's why it's classified as one. So let's try to find this cluster inside this dendrogram. I think it's somewhere Pontiac Firebird here. and the Camaro. So yes, it's within this cluster here. Notice that it doesn't have to be exactly the same as what's shown here, or the order doesn't have to be the same, but it's within the same cluster. So you see we have the Pontiac Firebird, we have the Camaro X28, the Duster 360. Yeah, it's all there. Now why is it clustered in this way? It's because the parameters for each of the cars have a similar magnitude or similar variation that makes them be grouped into one cluster. Similarly, the dendrogram shows that the 1974 Honda Civic and Toyota Corolla are close to each other. So this is another cluster, and I'm sure you can find this inside the dendrogram. So in general, there are many choices of cluster analysis methodology. The H-class function in R uses the complete linkage. This is the default method for hierarchical clustering. This particular clustering method defines the cluster distance between two clusters to be the maximum distance between their individual components. So cluster analysis is all about grouping, and here the complete linkage means that it groups the data into different clusters that gives the maximum distance between each cluster. So at every stage of the clustering process, because it does it step by step for every point, the two nearest clusters are merged into a new cluster. The process is repeated until the whole data set is agglomerated into one single cluster. That means it's all combined to the top. So you can actually see that here. So this is all the different clusters. You can actually, if you cut it down here, at the bottom here, you can actually, each cluster is a row. And as you go further up, then you have a lower number of clusters until there's only one cluster at the top. The process is repeated until the whole dataset is agglomerated to one single cluster. For a dataset with 4,000 elements, it takes H-class function about 2 minutes to finish the job on an AMD Phenom 2 X4 CPU. Now this is an old CPU. Now I think this is about, now it's 2020, so this is probably about 5 to 10 years ago. So it takes them 2 minutes if it's 4,000 elements. For this particular example, it doesn't take that long. It was actually very quick. It was instantaneous because the number of observations is only 32. So it's not really an issue, but if you have large data, rows of observation, then it might take more time to run the cluster analysis. So this is actually just code to show you the performance between different types of cluster analysis. So here it says we create, for this example, we create a variable called test.data, and this is a function. This is not really important for you right now. This is basically a way to create the data, artificial data, to test the performance of the cluster analysis. So here, this is the use of the data, and here it says, if I'm not mistaken, this is the number of rows, and this is the number of dimensions and the number. Okay, so the dimensions here is 120 columns with 4,500 rows. So this function actually creates a random data, artificial data that has 120 columns to 4,500 rows, and then we run the data through a cluster analysis. This is a separate package that enables us to use this function called RPU_dist, and then we run the RPU_dist function using this M generated data, the one that contains the 120 columns and 4,500 rows, and then we time it. So this is not exactly hierarchical clustering analysis, and then I don't expect you to be using a few thousand rows of data, so it might not be a problem, but this is interesting if you like to assess the performance of this, because usually when you run cluster analysis or any types of exploratory data analysis, it's not just for a few tens of rows, but usually for millions of rows. So when it goes to that magnitude, the amount of time it takes to run the analysis is important, because it can go up to weeks even if you do not optimize it. So by code optimization, the RPU H-class function in RPUD package or library equipped with the RPU D plus add-on performs much better. Moreover, as added bonus, the RPU H class function creates identical cluster analysis output just like the original H class function in R. Note that the algorithm is mostly CPU based. The memory access turns to be too excessive for GPU computing. So this is just another function you can use to run high performance cluster analysis on the data if you need performance to analyze your very large data sets. So this is actually a comparison between the one that you learn H class and also the RPU H class function. They produce the same results except for if you use the H class, the time it takes to run the analysis is exponentially higher, but the ones that you apply RPU H class, another function that's more optimized, it's much lower in magnitude.